Greetings, SIGCHI members. My name is David Smith. I want to thank you for the recognition you've given my work and for inviting me to speak with you today. I very much appreciate it. In my 50 years of working on CHI issues, the question I'm asked the most is how I came up with the idea of icons. So I'm going to talk about that today, as well as what icons are and how they can best be used to improve user interfaces. The story of icons. It began back in the late 60s when I was a graduate student in computer science at Stanford. And the professors would assign us problems to work on. And a group of us would get together in a room to brainstorm solutions. There was always a blackboard in the room. If there wasn't, we typically didn't make as much progress. So the way it would work is we'd go to the blackboard and sketch out some images, data structures, flow of control, algorithms, and so forth. And then we'd step back and examine it. And we would say things like, oh, we left out a case. And we go back to the board and sketch in some new images. And then we would step back again and say, oh, that's not right. And we'd go back and fix some error or other. And finally, we would step back and look at it and say, that appears to be correct. And more often than not, we were right. So the process was collaborative brainstorming using a blackboard and solving problems by visual inspection, both of which are powerful problem-solving techniques. Then we had to translate the images into a programming language. This is where problems arose. The translation distance between the images and linear code was large. Trying to bridge the gap introduced errors, both logic errors and syntactic errors. It occurred to me that if we could just directly execute the images, we'd be done. And it would eliminate a whole class of errors. So that was my aha moment. I decided to make this the goal of my thesis research. Pygmalion, an executable electronic blackboard. Pygmalion contained two new ideas, icons and programming by demonstration. I'm going to spend most of my time talking about icons, but I wanted to mention programming by demonstration briefly. It's a technique by which the programmer leads the computer step by step through the definition of an algorithm. It's exactly the way humans teach one another to do a task. It seemed to me that people might have an easier time with this way of instructing a computer, particularly people who had never programmed before. What is an icon? Well, there's one subtle characteristic. An icon in the computer sense is an image on a computer screen that has two kinds of semantics. Visual semantics, what it looks like, and computer semantics, how it behaves in the system. Here are a few icons from Pygmalion, and they're all programmer icons. Things like variables, conditionals, procedure calls, data structures. If we examine one of them, we can see the dual nature of the semantics clearly. The variable icon looks like a box, so you would expect it to hold something. And it acts like a location in memory. In other words, if you drag something out of it, it's like doing a fetch command in a programming language. If you drag something into it, it's like an assignment statement. So here's an example of programming by demonstration using icons. We're going to define the factorial function. If n equals 1, then 1, else n times factorial of n minus 1. Here is the environment I implemented. I incidentally used the brand new Alto computer that the Park people had invented, and the brand new Smalltalk language, programming language, which Alan Kay's group had invented. The large white area is the electronic blackboard. The terms down the left side are operations that create icons and modify them. The areas at the bottom aren't really important. It's kind of a clunky user interface, which I apologize for, but this work was done in the early 70s, 5 years before the Apple II came out, and 10 years before the Macintosh. So let's get started. I'll show you how things were programmed in Pygmalion. The first thing I do is I create an icon for the function using the create operator. And then I create a couple more sub-icons for the argument and value, maybe some crude graphics. And I think I'll hide the border. And so there's my icon for the factorial function. Well, let's try it out. So I'll type a value in, say 6, and I'll say eval. Pygmalion had an eval function just like Lisp. Well, it doesn't have any semantics yet. I haven't told it what to do. But every code thread starts with one operator, the trap operator, which, if it's ever reached, comes back to the programmer asking for what to do next. So that's what happens here. And when the trap operator is executed, it automatically enters a remembering mode where it records the actions that I do. So what should we do? Well, the first thing we'll do is move the icon out of the way to give us some room for sketching. And we'll bring up a conditional icon and a Boolean. We'll drag the argument down into one side of the Boolean. And we want to check if n equals 1. So I'll type a 1 in the other side. When both arguments are present, it automatically evaluates. 6 is not equal to 1, so it evaluates to false. And then I drag the false value into the question mark part of the conditional. This causes the false branch to attempt to be executed, but it doesn't have any semantics yet either. So it traps back to me asking for what to do now. Well, let's see. The first thing we'll do is we'll get rid of the Boolean and bring up a couple of more icons, a multiplication and a subtraction one. I'll drag the argument into both of them. I want to compute n minus 1, so I'll type a 1. 6 minus 1 is 5. And now I want to recursively call factorial, the very function that I'm defining. So I use the call operator to call it up. And I'll fill in its value with 5. And I'll say eval. Now the factorial function has quite a bit of code. We're in the middle of defining the false branch of the conditional. So it goes screaming down through the recursive calls until it hits factorial of 1. Well, in that case, the Boolean is 1 equals 1, n equals 1. And so yes, 1 does equal 1. So this time it evaluates to true. And when that's put into the conditional icon, it attempts to evaluate the true branch. But that doesn't have any code yet either. So again, it traps back to me asking for what to do now. Well, 1 factorial is 1. So all I have to do is type a 1 into the value box and say done. And when I say done, it removes the trap operator because this branch of the conditional is now fully specified. So I also say return, which causes this recursive call to return. It was called from when n was equal to 2. And so I've dragged the one value out of the factorial call. 2 times 1 is 2. So now we have the value of 2 factorial, and I put it in the value box and say done. Now the false branch is completely specified, so it goes screaming back through the recursive call stack, finishing all the recursive calls, and we end up with 720 as the final value. And now when I say done, the function is fully specified. And when I say return, it clears away all the intermediate icons it's used and restores the display screen into the state it had when the function was called. 6 factorial equals 720. So this was the first use of icons on a computer. And it demonstrated a novel way to program using only images. Here is the code that got recorded during the demonstration. It's pretty low-level stuff, kind of like a virtual machine language. In fact, I wrote an interpreter for it, which executed pretty efficiently. So I was done. I implemented Pygmalion. It worked as desired. And we were beginning to wrap things up. So one day I was sitting in LNK's office and we were discussing what to call these things that I was programming with. They couldn't be called pictures or drawings or images or things like that because those concepts have only visual semantics. Ellen suggested the term icon because in Eastern religions, an icon is a picture of a sacred person or event. It is regarded by adherents to those religions as having some of the holiness of the thing portrayed. That is, it both portrays a sacred object and is a sacred object. 2 kinds of semantics. Bingo, that was our term. And the term seems to have caught on and is in wide use today. So I was done. I finished my thesis. I got a degree, which I'm thankful for. And coincidentally, right about then, Xerox decided to start a project to turn the Alto computer into a product. It became known as the STAR project. And the target market for STAR was knowledge workers in an office. These are researchers, staff members, secretaries, but not managers, because the conventional wisdom back then was that managers don't type. That seems pretty silly today because any manager who doesn't use personal computers is going to quickly become obsolete. Well, the problem that faced us designers was that office workers were adverse to computers in the 1970s. They were competent in their jobs, they did their jobs efficiently and effectively, but they had never used a computer before. Computers were big things that sat in air-conditioned rooms, on raised floors, with lots of cables running under the floors. Nobody in an office had used one of those. So I was sitting in my office in the STAR project, which I had joined in 1976, thinking about metaphors. Metaphors in a user interface is the technique of making a system appear and behave like something else. A good metaphor is familiar and non-threatening to the target audience. And the importance of this concept is that when confronted with a new situation, people try to bring their existing knowledge to bear to understand it. A good metaphor can help people do this. It can reduce their learning time, their stress level, and increase their enjoyment. So instead of trying to bring office workers into the computer's world by teaching them things like command line interfaces and computer terminology, we would bring the computer into the office world. So I had the perfect vehicle for doing that. Icons, which I had just been experimenting with. So I recast Pygmalion's programmer icons into office terms. I literally looked around my office and created an icon for everything I saw. Documents, folders, a file cabinet, a clock, a telephone, bookcase, a wastebasket, yes, even a wastebasket. Icons were powerful enough to model those objects because of their computer semantics. STAR's icons looked like common office objects, documents, folders, file cabinets, wastebaskets, and they behaved like those objects. STAR's display screen became a metaphor for a desk in an office. People loved it. Here is a screen image from the actual STAR product. You can see some icons in the upper right. I'll talk about those in a minute. And one of them is open to show that STAR documents can contain multi-font text and graphics. This was so successful with people of all levels of experience that it became quite popular in the industry. For example, Apple immediately copied it almost verbatim when they came out with the Lisa computer in 1983, a year after STAR. And a year later, they came out with the Macintosh. And both of them duplicated these ideas almost perfectly. Here are a few of the icons that we created in STAR. They're all pretty familiar in an office context. For example, the upper left one is a supply cabinet. You can go there to get other kinds of icons. Next to it is a file cabinet. Then there's a couple of terminal emulators. Somebody thought that was a good idea. And then we have a couple of laser printers, some folders, a couple of database icons, a couple of people icons. Those can be used for things like distribution lists and group access. Then a couple of mailboxes, an inbox and outbox, and a few documents. All of these icons came with some common semantics. Open and drop on. You could open an icon to see what was inside it. You could drag an icon with a mouse and drop it on another icon, which would cause the recipient to execute some code. For example, if you dropped a document icon on a printer, some paper would start coming out somewhere. One interesting side effect of these semantics is that icons made the interface to remote resources the same as to local ones. For example, I could have two printers on my desktop, one bound to a printer in another city and one bound to the printer down the hall. I would interact with them in the exact same way. Drag a document over to it and drop it on it. If I dropped it on the remote printer, paper would start coming out hundreds of miles away. To sum up, people loved this interface. They felt very comfortable with it. We got some wonderful testimonials from people talking about how easy it was to understand and use. And the ultimate legacy is that icons have been adopted by every major computer manufacturer, including Apple and things like the Visa and Macintosh, and even the iPad, and Microsoft in Windows. And icons are used daily by billions of people worldwide. Thank you.